This is the second workshop in the spring 2013 edition of the Basic Bioinformatics Tools series that we are doing, the Center for Bioinformatics is doing in collaboration with Health Science Library. We are going to be looking at a slightly advanced introduction to Unix today, and we're going to talk about compute resources that are available here on campus for use. Even though we are going to be using a server called KillDevil, which is more of a general purpose compute cluster, if you have an account on Curie, which is the other compute cluster that is available on campus, most of the things that we are going to be talking about today are equally applicable on that cluster as well. Both clusters use the same software module system that I'm going to be talking about in just a bit for managing different versions of software. And essentially, the compute experience you are going to have is going to be seamless whether you're working on Curie or whether you're working on KillDevil. So for today's session, I'm guessing all of you have already gone ahead and opened the SSH program and logged into KillDevil. We'll go through a small number of slides. I won't go through all of them. The rest are obviously going to be available for you to refer to afterwards. We'll go through a small number of slides and then dive in and start doing the hands-on part of the session. So last time I had talked about compute clusters a little bit, but I figured I'll put in an image here so that you can have a better idea of what we are using today for this class. We are actually logging into this master access node, what's referred to as master access node in this image, which is basically the Curie login node. So this actually happens to be a server that sits in front of the actual cluster of computers which are interconnected on the back end. And we generally interact with the compute cluster only through the login node. So we are not actually directly logging into any of the individual nodes. We are going to be doing all of our interaction with the server through the login node. So this is basically us interacting with the login node, which in turn manages the distribution of the jobs we submit to the compute cluster. I've already said this, we log into the head node. You're not supposed to run programs here. You may have already seen some recent emails where people sometimes get carried away and start running something on the login node itself, which leads to exhaustion of either the memory or the other compute resources, basically leading to the head node being hung, and at that point no one else can log in. So you don't want to be that person, because if you do that one too many times, they're going to basically come after you and you may get your user privileges suspended. So just make sure that you use the head node for things like compiling, editing. That's all you generally should be doing on the head node. Both the ITS compute clusters use a system called LSF, and I'll talk about that in a minute, for job queuing, which is what actually manages the submission of jobs on the back end. And if you want to get a little bit more information on how KillDevil is configured and what different systems are available on KillDevil, you can refer to this link from the help page. So load sharing facility is a commercial product from a company called Platform Computing, which was recently acquired by IBM. What load sharing facility is a collection of programs that is used for workload management for high performance computing. Now the advantage, as we've talked about last time, is if you are managing your jobs through the load sharing facility, it basically allows you to log in after submitting a job, and the jobs will keep running. Because normally if you're doing an interactive session and if you start running a program and happen to close that terminal window, then that program immediately gets killed. Load sharing facility will automatically send you email notification to your Onion email once the job completes, so you don't actually have to periodically check whether a job has completed or not. If the output of your program is small enough, it will generally be attached to the email that you get itself. So you may be able to look at your email and figure out if the program worked correctly or not. More information about LSF is again available at this help page URL. So let's go back and start talking about some of the LSF commands. So I'm going to switch back to my shell here, and the commands that I have listed here on the slide are generally going to be some of the commands that you will end up commonly using. There are obviously more than these. So the most common command you're going to be using is called bsub, which essentially sort of stands for batch submission. So you're submitting your job, whatever program you're running, to a specific queue. As I said, the queuing system actually has more than one queue that are available, and depending on how your access is set up, you may or may not be able to use one or more of those queues. Remember, we've talked about access in terms of access to storage systems as well. There are obviously more than one storage system or partition available on big clusters. You may or may not have access to all of them. Let's go ahead and run this command called bqueues. So if you say bqueues lists all the different queues that are available on this compute cluster for submitting jobs. And the names that are being used for these queues, again, are fairly self-explanatory. There are queues for jobs that can run up to an hour. So if you know that your job is going to finish within an hour, you can submit jobs to that particular queue. Day and week queues obviously mean what their names say. They allow the jobs to run for either a full day or a full week. There are some specialized queues available here that are meant for running jobs that require, for example, a large amount of RAM. This big name queue actually is accessing a couple of nodes that are present on this cluster that have a terabyte of RAM each. Again, these queues are basically meant to run jobs that do require something along those lines. I mean, you obviously don't want to run a small blast job on a big mem queue because there's really no advantage there. There are some specialized queues that the staff uses for submitting jobs. One of the things to remember here is if you are copying things from, let's say you've done some work in the netscratch directory. We've talked about the netscratch directory last time, which does not have a quota, and that's where we'll probably end up working today. If you wanted to save a copy of something you did in your netscratch directory to the mass storage, which is available. So mass storage is the tape storage backup that is available on all the ITS clusters. So you can subscribe to the mass storage system again through the Onion page, just like you signed up for the KillDevil account. If you haven't done so, you can go back to the onion.unc.edu and sign up for the tape backup storage service there, which will allow you to move your files that you want to save from your directory. So who can tell me where did we land? How do we find out which directory we've landed in? PWD, all right. So as you remember, by default, we always land in our home directory, which is designated by the system administrator. Just a quick review of things we did last time. Describe file systems is going to show you all the file systems that are available on the cluster. And you can see that there is a /ms home file system available, which basically is the destination for doing your backup. So if you want to back up some data from the netscratch directory, for example, there should be, I'm fairly sure, a directory in /ms home, or we may need to create one. I guess I have not looked at the MS directory on this particular cluster, so let's do that really quick. So yeah, it looks like this is organized in the same way, so we're going to have to do our, just like my home directory is set up. With the first two initials of my onion, I'm guessing they are now doing the /ms home directories in the same way. So if we go down probably in the ms home k/e/kelkar, that's where I would basically put things that I want to back up, and they would automatically get backed up. So we've talked about the queues. So B queues, again, shows you all the queues that are available. There is a particular field called priority, and depending on whether you have access to these queues, a higher number generally means a job that you submit to those queues will run with a priority above other jobs that may be running on the system. What LSF does is, as you can see, there are 2,000 job slots that are currently available for the day queue. This is a pretty big cluster. We have 8,000 plus cores available for computing on this particular cluster. But you can see that even though there are 2,000 plus cores available, there are still a number of jobs that are pending. So that means once you exhaust a certain number of job slots that are available, the system basically is going to pen the rest of the jobs. So if you submitted, for example, 50 jobs, there is what's called a fair use system that LSF uses, which determines how many jobs you can run. So even if you submit 50 jobs, it doesn't mean that all 50 are going to start running right away. Depending on the allocation you have, let's say maybe 24 of the jobs will start running away. So that means that you have permission to run 24 jobs at a given time. So once one of those jobs finishes, the 25th jobs automatically get started. So you have a quota, and then there is a fair use system that determines how you use your quota. And then on top of that, this priority listing will determine if someone else has a higher priority queue access, that basically will even pen a job that may have started running. So for example, if you have started running a job in the day queue, and someone comes along and submits a job to the patrons queue, which has a higher priority, then the system might actually stop your job and allow the other person's job to start working right away. So that's the advantage of working through LSF. System will automatically take care of running, stopping your jobs depending on how the load of the system is at any given time.